Afternoon, guys. Is it audible? Someone please respond. Okay. Today is weekend. People are not attending on time. All right. Yesterday we had discussion on different type of time complexity with the real-time program scenario. I had shared the notes. Did you go to the notes, everyone? Yes, no, anything you respond? Okay. Let the Eclipse open. After that, we'll be starting our session. All right. Okay, so yesterday we discussed about the complexity in data structure, where the complexity refers to the amount of resources such as time or memory that an algorithm or data structure consumes when we perform an operation. Complexity basically involves two aspects: time complexity and space complexity. The time complexity was nothing but it is something that measures how the execution time of an algorithm or operation grows relative to the input size. So it basically gives us an estimate of how long an algorithm will take to run as the input grows. And it is more often expressed using the big O notation. Big O notation means the upper bound, means the highest it can go for. So the big O notations that we got for the time complexities are big O of 1 that represents the constant time whenever you access element from a array using the index. Then we had big O of log n logarithmic time, big O of n linear time, big O of n logarithmic time we saw it with binary search. Then big O of n with linear time we saw with the linear search. Then big O of n log n. This one is nothing but combination of logarithmic and linear. So this one was mainly coming under merge sort, where the array was broken into half, then the further process was continued. Then we right now have big O of n square and big O of 2 to the power n. That is quadratic equation, quadratic time and your exponential time. So shall we continue this one today? All right. Now, big O of n square. What does that mean? Sir, big O of n square means it refers to an algorithm whose performance it refers to an algorithm whose performance is proportional to the square of the size of input. We'll try to understand how it works. It refers to an algorithm whose performance is proportional to the size of the input. All right. Now, when it happens in it happens when an algorithm involves nested iterations over the input. Okay. And the time complexity will result in n square. Okay. So let's say it happens when an algorithm involves nested iteration. Nested loop, you remember? One loop inside another loop when we were doing that pattern programs and your, what is that, multi-dimensional array. We saw the nested loop there. So nested iterations we found there, na? Like, for example, there is a sorting technique. We have to sort the elements in an array. There you will be getting big O of n square because there will be nested iterations. One loop inside another loop where the elements are compared and then swapped. Okay. The algorithm also I'll show you how to write the program for the sorting. All right, let's continue with this point. It happens when an algorithm involves nested iteration over the input data, resulting in input data, let's say, resulting in a time complexity of n into n. Okay. So when do we use it, sir? When it comes, sir, in real time. When it comes in real time. So I can say here, wait a second. Now, let's say it's common in algorithms that involve checking every element. Like in sorting, we check every possible pair of elements, such as in certain sorting, in some sort of in kind of sorting algorithms and operations on list or arrays. Okay. So let's say, for example, there is a sorting technique, bubble sort. What is the bubble sort? Sort means what? Let's say, for example, you're having elements somewhat like this. Here, 10, 30, 40, and 20. Now tell me, is it a sorted array or unsorted array? Sorted means arranged in an order, maybe ascending order or descending order. Is it sorted or unsorted? Very good. This is an unsorted array. Very good. Now, in that unsorted array, I need to sort it. How will I sort then, sir? To sort it, what I have to do is the elements whichever were available. Let us say 10, 30, 40, and 20. Let's say we'll sort it. How will sort? You have to take out 10 first. Take out 10 from here. Hold 10 in your hand. And then compare this 10. Suppose I want to sort in ascending order. Okay. I'm going to sort in ascending order. Ascending order means the final outcome will be 10, 20, 30, and 40. Smaller number to the bigger number. Nothing but ascending order. Suppose I want to perform this ascending order sorting. So 10 will be taken out in your hand. You're holding 10 in your hand right now. Now you take 10 and compare with the next element. What is there in the next element? 30. So compare. Is 10 less than 30 or not? Yes, less than. No need to do any kind of changing. Then compare 10 with 40. Compare 10 with 40. Is 10 less than 40? Yes. Let it be. Don't make any change. Next, is 10 less than 20? Yes. No need to do any kind of changing. No need to do any swapping here. Means adali badali. 10 will go there, 20 will come there. No need to do that. Next, for the 10 iteration is over. Next value that you will take out is 30. Take out 30 now, hold it in your hand. Take out 30, hold in your hand. When you're taking out 30 and holding in your hand, now 30 already compared with 10. So no need to further iterate with 10. What you have to do now? Take 30, compare it with the 40. Check. Is 30 less than 40? Yes. No need to make any change. 30 and 20. Compare here. Is 30 less than 20? No, sir. So what I will do? I'll shift 20 to 30 and 30 to 20. Swapping will happen. Adli badli. So right now, what is the final? What is the array I'm getting? I'm getting 10, 20, 40, and 30. Is it sorted yet? No, sir, because we have not compared all the elements. Na? Next, take out the next element. What is the next element? 40. 40 will come out. Now, for with the previous element, it is already compared. So I'll not compare it with the previous. What I will do, I'll compare with the next. 40 and 30 comparison done. 40 less than 30? No. So swap it again. 30 comes in place of 40, 40 goes to 30. So what will be the final one? Final is 10, 20, 30 and 40. Work is over. This is how you will get the bubble sorting. Did you understand the story? If you understand, then after that we'll go with the code. Okay. Now, how to write it in code, sir? I'm talking about a context. I want to meet and talk with you, sir. Please, is it possible? Okay, Krishna. When you come for any of the course in Naresh IT, when you come for offline, you can just come and visit. Okay, now come back everyone. Okay, you can come to the Manjira building. I'll be there. I'm having lab after this. What do we call this? This Leetcode webinar. After this webinar, you'll be finding me in the lab by 4:30. From 4:30 to 8:30, I'll be there in the lab. Before that, I'm completely packed with my sessions. All right. Okay, let's focus. By the way, from which batch you are, Krishna? You have opted any course here? Okay, you are attending Spring Boot right now. Okay, nice. You're attending it from legend faculty. I'm having lab in the Manjira building. I'll always be there. Currently, one of my batch is there, Java 41 in the evening. So I'm taking care of them from 4:30 to evening 8 o'clock. And these days they're having extra sessions. What do we say that some backup sessions I'm conducting these days, so I'll be there till 8:45 to 9 o'clock also. But I think today we are having exams, so I'll not be will not be available after 6:30. All right. Okay, chalo, come back to the context here. Now, how do we perform this sorting, sir? For sorting, let's say, for example, I'm designing one method, public static void bubble sort. So bubble sort requires an array. That array I have to sort. How will I sort? First of all, I'll take the length of the array. Let's say n is equals to arr dot length. What it is giving? It is giving me the size of the array because I have to iterate through the elements of the array. So whatever is the array size, that one I require first. Next, I will take support of nested loop, where the outer loop will represent the first element. Inner loop is meant for keep on checking the first element with all the elements. So when second iteration happened, I will represent the second element. Then J will represent all the comparisons for remaining elements. So I is equals to 0, I less than arr dot length, and then I plus plus. With the help of this outer loop, I'll take out each element at a time. One element I'll take out. Then that element I have to compare with further elements. So I'll take another loop, that is J is equals to 0. And then J is less than, instead of arr dot length, I can write n also because I have already stored the length. So I'll say J is less than n minus 1. Why n minus 1, sir? Reason is that when you're comparing the elements, array is there. You're comparing the elements. We're taking the length, na? Okay. So here 10, 20, and 15. So when I'm going from one index to another index, the final index is 2. So if I reach to 2, the further next element should not be compared, na? I should reach up to here and then stop. So for that reason only, I'm taking -1. I should not reach to the end directly. If I reach to the end means one extra element I'll try to access and I'll get exception, that is array index out of bound exception. I'll show you that with practical also. Now what I will do, I will start swapping elements. Okay. Based on comparison. How will I swap? I'll say if the element present at I for the first time when outer loop executes, I value is 0, but J value will increment multiple number of times. So if array element present at let's say I, and then I'll compare it with array of J plus 1. What I will do, I'll swap. Okay. Only one symbol you will change. The logic will change after that. I'll show you. Right now I'm giving greater than, na, you will see what will happen if I'm giving greater than, and if I give less than, what will happen. What I will do is I'll take a temporary variable in which I will store the element, the first element that I got, and then that will be swapped further with array of J plus 1. Later, array of J plus 1 will be swapped with the previous element, nothing but the temp. And then your swapping is done. So let's try to execute it in our program. I have a main method. In the main method, I'm going to write that logic. Wait, this method should not be declared inside another method. It should be outside the method. No. What I'll do is I'll take an array int arr in which there are elements. The elements are 10, 30, 20, 40, and 20. Now let's say before sorting, what are the elements? Arrays dot. I'm using predefined class arrays available in java.util. Arrays dot toString of arr. All the elements from the array will be displayed. Then I'm writing after sorting. After sorting means I'll call the bubble sort for ARR. So after sorting, I'll say arrays dot toString for ARR. So let's see what kind of sorting is happening, ascending order or descending order. What's happening to this again? Execute try. Getting stuck sometime. Hold a second. Wait. Before sorting, we got 10, 30, 40, 20. After sorting, what we are getting? 10, 40, 30, 20. Sir, is it sorted yet? No, sir. The statements what we planned is not matching yet, sir. That means what? Problem is with the statement or problem is with the code? Come on. Problem is with the code or problem is with the statement? Problem is with the code. So what should be done, sir, here, sir? What mistake happened here? See, without doing this type of trials, you're not going to get it. That's why I'm asking you guys to do this type of thing. For the beginners, I'm saying, if you are starting the code, if you'll not find the output, don't get stressed out. Just debug the code or just dry run the code. Check what is happening with this code, why it is not working out. Then you will find the solution that where you have to make changes. Getting it? So can you just do a quick dry run and let me know where is the mistake here? Here only some mistake is there. Tell me. If I take here J and then I perform the sorting, what is coming up? First element skipped. If I say here I plus 1 and then I say array of I greater than array of J plus 1. Is it sorted now? Tell me, sir. Is it sorted? No, sir. Still not sorted. Because where we are missing. Think like the system once and just do the rough of it, do the dry run. If the value is I value is 0, put the values. What is happening here? Check once. Check. My coding technique will be like this. I will do the wrong code in front of you so that your brain will start activating. Oh, this is missing. I want that. Because if you're not thinking like the system, then gone. No one can help. Sir, maybe here, sir. Array of J and then array of J is equals to array of J plus 1 and array of J is equals to 10. Swapping here, sir. Sir, still not working, sir. Think. Okay. Look at here. I take I is equals to 0, I less than n minus 1, I plus plus. Then I'll say int j is equals to 0, j less than n minus I minus 1, and then j plus plus. inside which I'm going to check if array of j is greater than array of j plus 1, then the temporary value will be is equals to array of j, and array of j is equals to the next element j plus 1, and the next element, that is j plus 1, is swapped with the temporary value. Now check, sir. Is it sorted now? In which order it is sorted? Ascending order. Sir, I want in descending order. Simple. Here you just make a less than symbol. Tada. Khatam. Easy. Okay. So here we are iterating through the element in a nested loop, due to which our complexity here we have to accept that the complexity is quadratic time complexity. This algorithm is involving nested iteration over the input. This algorithm has to be a little bit changed here. Here is the algorithm. Nothing but your bubble sort. Getting it? Now, like in bubble sort, we are having one more algorithm, that is selection sort. Here what will happen? Repeatedly, you'll have to select a minimum element from unsorted array and then swap it with the first unsorted element. Okay. Here what will happen? It repeatedly selects the minimum element from the unsorted portion of the array and swaps it with the first unsorted element. Now, how does that work, sir? First of all, you have to take out the minimum element. To take out the minimum element, you need to take the help of loop, in which you'll take out a index of I, outer loop. Then you will compare. How to do that, sir? Let's see. Easy thing. Very, very much easy. Public static void selection sort for an array. We'll take one minimum element from the array. Let's say, first of all, I'll take the size of array. I don't want to keep on writing array.length again and again. So I'm just taking the size of the array and storing it in n. Next, I is equals to 0, I less than n minus 1, I plus plus. Inside which there will be inner loop. But before the inner loop starts, I'll take the minimum element, the minimum index. The minimum index is going to be 0 for the first time. So I'll take I. Next time it will change to 1, then 2. Like that, I'll keep on switching from one index to another index. Then j is equals to I plus 1, the next index. J is less than n, and then j plus plus. All right. Now here I have to check if array of j is less than, if array of j is less than array of minimum index, element present in the minimum index, then the minimum index is J. Based on index, we are performing this task. All right. Now, outside the inner loop, you have to swap the found minimum element with the first element. How will I do that? For that, swapping int temp is equals to array of minimum index, element present in the minimum index, and array of minimum index is equals to element present at I, which I took earlier. Then array of I is equals to swap it with the temp. Okay. Algorithm is ready now. Let's try this algorithm over here. In place of bubble sort, I'm going to say selection sort. Let's see whether it is working or not. After sorting, we are getting the elements in ascending order. Sir, I want in descending order. Then do one thing. Change that symbol. Now we got in descending order. Right. These are the examples of bubble sort and selection sort. So the outer loop will run for like n times and the inner loop will run for n minus I times, where the complexity will lead to big O of n square. Now suppose for example, you are checking for the duplicate elements in array. Then also you are going to get the complexity of big O of n square. Okay, you want to check whether in an array we are having duplicate elements or not. Let us say, for example, one more example we'll take. Checking duplicates in array, whether array contains duplicate elements or not. For that, one logic we'll design here. Public static, let's say boolean has duplicate for an array. So what I will do, again I'll take the length. If you will not take the n here, no problem. You can directly write arr.length also in the loop. Next, int I is equals to 0. I less than n, I plus plus. Outer loop. Then we got the inner loop where j is equals to I plus 1. J is less than n and then j plus plus. You have to check duplicate is available or not. So take out a element and compare with all the remaining elements. If array of I is equals to array of j, the element that I took out for the first time, if that matches with any of the element present, then return true. Getting it? In the outer, we are keeping return false. There are no duplicates. This is for no duplicates. This is for duplicate is found. Here, duplicate found. Return false only when duplicate is not found. All right. Now let's check this, whether it's working or not. Here, let me provide some duplicate elements. Now, we'll call that method for hash duplicates with ARR. So let's say array has duplicates. If array has duplicates, I'll get true. Yes, I'm getting true. Now I'll remove the duplicates from here. I remove the duplicates. Now array has duplicates, false. How do this all three algorithms are working, sir? Do you require the dry run of it, guys? Let me take the dry run for smaller size of array. In small array, I'm taking 10, 30, and 20. Someone suggested the paint yesterday. Let me try with the paint. Alright then. Now see, for the first time when I'm going to execute it, the loop, if I'm having an array, somewhat like this, a small array I'm going to take. I will take this small array. I don't want to deal with more elements right now. Otherwise, it will take a lot of time to explain in the dry run. Now, the elements stored in array are 10, 30, 20, and 7. I want to sort it, sir. So how is this sorting happening here for the descending order? I'm taking the loop here. The outer loop starts with I is equals to 0. I value right now 0. It's not easy to handle it. My iPad is also not working. Otherwise, it would have become easy. Let's say I value is equals to 0. Then check 0 is less than nothing but I is less than n minus 1 or not. I value is 0. 0 less than n minus 1. Total length is 4. 4 minus 1, 3. Yes, it is giving us true. It results in true. If it is true, go inside the loop. WebEx internals, I tried it. I'm not used to it. Thus, I'm not using it. That WebEx internal, that annotation, I know. I'm not using it. It becomes a little bit clumsy for me. Okay, now, after this, j is equals to assigned with the value 0. Then check j is less than n minus I minus 1 or not. What does that mean? That means 0 less than n. N value is nothing but your 4 minus I value is 0 minus 1. So 4 minus 0 minus 1, nothing but 3. So check here, 0 is less than 3. 0 less than 3. Yes, it's true. If it is true, check if array of j is less than array of j plus 1. What is there in array of j, sir? Array of j means array of, put the j value, 0, less than array of j plus 1, 0 plus 1, 0 plus 1, nothing but 1. So in array of j, what array of 0, what do we have? In array of 0, this is array of 0, this is 1, this is 2, and this is 3. So here, what we are having? Array of 0 means 10, element 10. Sir, check 10 is less than array of 0 plus 1, that is 1. 10 is less than 30. True or false? True na? So we'll do this swapping. 1 second. You'll do the swapping. Swap it. Swap it. Then further you continue the process again. J value will change. J value will become 1. Then same story you start. Then again do the swapping. if it is matching. Then again do the swapping. For every element you will swap, sir. Are you getting it? Similarly, just like to your selection sort also, each index will take out first. After taking out the index, you'll keep checking the element based on the J value and index value. Check the elements and then you assign the middle index, so the minimum index. After then, once the loop is done with its work, when you are exiting the outer loop and going for the inner loop update, just swap the value and then again continue the further process. Next, we are having the duplicates. For the duplicates, each element is taken, compared with the next element. If matching, true. Otherwise, in the end, will return false. Got it? There are a lot of programs. Matrix is there, like matrix programs, like matrix multiplication. There are also big O of n square. Then finding, what do we say that? Finding what do you say? Finding a pair in the list. That time also, like your target, that Leetcode program was there, no? Target sum. Remember Leetcode program, target sum program. The two sum Leetcode. There also big O of n square. Finding the pairs. There are also big O of n square you'll be getting. Can you come up with an algorithm that is less than big O of n square? Just have to design something which will be less than big O of n square. Follow up. First you design it. How to design that Leetcode program, sir? That Leetcode program. Which two numbers are available in the array? When they are added, gives the target. For that, let us say, for example, there is an array. In the array, we are going to load some elements. 10, 3, 15, 2, 7, 8. Leetcode, very much famous program. To sum. For this, I need to find the pair of elements. I'm not writing the exact same solution. Sorry, the same question solution. I'm just in that question, you have to return the indices. Here, I will be displaying the elements which when added will give you the sum. Okay, we'll try. Let's try this one, sir. With int ARR for a target in an array, give one value as a target. From the array, which two elements are added to reach that target? That is the question. So if I go for the brute force technique, where each element I'm taking and comparing, n is equals to array of length, then I is equals to 0, I less than n, I plus plus, in which there will be a nested loop. J is equals to I plus 1, next element, then j less than n, j plus plus. In this, you have to check if array of I is equals to, or let's say array of I plus array of j is equals to target. This is a brute force technique, okay? You'll be getting the pair. So let's say pair found. And the pair is element present in array of I and element present in array of J. It is just a brute force technique. Let me invoke the method find pairs for, let's say, I will say here 9. So which two elements are added to get 9 here? Check it. 2 and 7 if added will get 9. I want to check which two elements are added to get 17. 10 and 7 and 15 and 2. Okay, I just tried to modify that Leetcode sum. With this same concept, I want you guys to solve this two sum program. Leetcode two sum program. Try to solve it. Solution I'll be giving after one day. On Monday I'll give, not tomorrow. Tomorrow also we are having the workshop. There is no holiday. On Monday I'll give the solution. I'm giving you 1 day of time to solve it. On dummy I tried once. Case 1, case 2, case 3. Should match all the cases. That one I tried once. Okay. I'm returning indexes here to an array. So if you execute this program, you'll get the indices. This program. So just try by your own ones. Do some Leetcode. Getting it? Or any confusion is there? The question is, this target is going to receive the value 17 here. I want to check that which two elements are available in the array whose sum will give us 17. So that is my target. I need to find it out. That Leetcode, that was little bit different. In the Leetcode, we have to return the indices. Here I'm not returning indices. Here I'm returning the values. I said I'm just modifying a little bit. Not the exact thing I'm doing, but the same similar, this code what we wrote, this brute force technique code, this one will be helping you for solving that Leetcode problem. I've done it using array. In future, you'll be doing it with map also. With map, you'll get better solution. I'll send the code for the map also. Using map, how will you solve that? The same question, the two sum. Better solution you'll get with the map. Yeah. Return digit nahi, return the I value. I and J value. Okay. All right. This is one of the code for finding two elements which when added results in target. Okay. All right. Now, one more is here. One more type of complexity, that is exponential time complexity. Okay. What does this mean, sir? Exponential time complexity. Big O of 2 to the power n. It is generally like what I'll say. It will occur when the time it takes to complete an algorithm grows exponentially. Whenever the input size increases, the time taken to complete the algorithm will keep on growing exponentially, and the algorithm's performance will double. It will keep on doubling up. Okay. But for the large input, it will be a little bit problem. For smaller input, okay. Okay. But when we will be having some problems such as like what do we say that? Combinatorics or recursion. In such scenarios, this exponential time complexity will be helpful. Okay. The base of the exponent is obviously going to be greater than 1. But yeah, this exponential time will grow very fast, man. The more the size of the input increases, the faster the exponential time will grow. Sometimes, yeah, I'll not go for it because sometimes what happens is even for like for some small input also, the number of operation can become like unmanageable. That's why I don't go for it more. The function grows very fast. You can have some like recursive algorithms if you're having for like if you want to solve Fibonacci series. You know Fibonacci numbers? Fibonacci series. For that Fibonacci series problems, the recursive algorithm if I'm using, where one method will call itself, in that case, I'll be getting this exponential time complexity. One example I'll show you. I'll show you that Fibonacci series, like a Fibonacci sequence, how do we get? Let's say, for example, public static. I'll return the last value from the series Fibonacci for n. All right. So if I say n is less than or equals to 1, then I will return just n. Okay. But later here, before the method, we are going to return Fibonacci here recursion happening. This method is calling itself plus Fibonacci of n minus 2. So mathematical formula. Okay. This is going to be good for the smaller number, but if you go for the bigger number, it will keep on executing continuously again and again, again and again. Maybe the execution will never stop. Still then you may not get the value. So the exponential time will grow a lot. It creates binary recursion tree, sir, where each node of the branches We'll have further, like two further cells will be there. If the number of input increases, the number of recursive call will keep on doubling, which will result in O of big O of 2 to the power n time complexity. Suppose, let's say, for example, I'll take Fibonacci for 5. Then the recursion will be 15 times. There will be 15 calls. And if I go for Fibonacci of 10, then it will be 2i, very much big. It will cross maybe thousands, it will cross. Pakka thousands, it will cross. Thousand of calls will happen. One method will keep on calling itself. So the exponential time will grow at all of a sudden. Sorry, the time will grow exponentially. Okay, the more is the size of input, it will keep on raising a lot. In array, if you are having the subset problems, there also you are going to have this, what do we say, exponential time for the subset problems also. I think one time there was a company named as IVY. In that IVY, once one question was asked to the student. This IVY, Comptact. In Hyderabad also we are having this office. In this company, I think 2 years ago, we got one question. One question was there for one algorithm, traveling salesman problem. Means where you can find the shortest possible route that visits each city exactly once and returns to the starting point. Yeah. The starting package was, I think, that time 9 lakhs, 2 years ago. There was some sort of like, you can handle the exponential algorithm. Like they wanted to see like whether people can handle the exponential algorithm or not. So in future, if you ever get any problem like that, where you have to handle exponential time complexity, I'll suggest you to go for some algorithm that is dynamic programming, and is one more very famous algorithm that is called as greedy algorithm. Famous algorithm, greedy algorithm. Okay. More other ways are also there. Other algorithms, like other methods are there. Like you can do some backtracking. That is, the term is what do we say? Backtracking and burning or pruning. Backtracking and pruning. Pruning. Yeah, backtracking and pruning. Okay. Then there will be something called as, one more was there, approximation algorithm. These all algorithms I'll share in notes. Don't worry. I'll share. It's easy. When you see the code, you'll get it. Then one more was there, like some rule of thumb, I guess. A rule of thumb for that, I think name exactly I don't remember. Stick or what was that? What is the name? Heuristic method. Heuristic method. Okay. These all are mainly focusing on solving one very much famous question for uh, traveling salesman problem. Very much famous. Big giant tech companies are also taking this question. Tomorrow is Sunday, na? Little bit you have to go through it. I'll explain. Obviously, I'll explain this. Yeah, ask. Okay, you are asking me what is this traveling salesman problem? Okay. All right. Yeah, there will be brute force solution only for that. All right. Okay, chalo. Let's see. What is this traveling salesman problem, sir? One of the important problem. Traveling salesman problem. What it does, sir? It is nothing but TSP. What is this TSP? TSP asks for the shortest possible route that visits a set of cities and returns to the starting point. Okay. Here you'll be like trying all the possible permutations of the cities, and you'll also calculate the total distance for each city. Okay. Generate all. You have to generate all permutation of cities and calculate the total distance for each permutation. Then select the one with the smallest distance. Simple. Correct. Two things you have to do here. One is distance calculation, another is generating the permutation. You have to calculate the distance of a given permutation by adding the distance between two consecutive cities in the path. And then another is you have to generate the permutations. For the permutations, you can use the recursion to generate all the possible permutation of the cities. Okay. That is also available. Yeah. Okay. That will be actually the solution is there, but it will be little bit with I'll take with the list because there will be a lot of input. Na? Okay, leave just see here what happens here. Traveling salesman problem asks for shortest possible route that visits a set of cities and returns to the starting point. Okay. So what we have to do here, how will you solve it? You have to try all possible permutations of the cities. People who don't know permutation combinations, please go to class 11th mathematics, little bit to study and come back. You'll get idea, permutations. Trying all the possible permutations of the cities and calculating the total distance for each. This is how you are going to solve it. Okay. So what we will do here, we'll generate all permutation of cities and then we calculate the total distance for each permutation and then we'll select the one with the smallest distance. Which one is the smallest distance? Okay. All right. Let's say, for example, will I take? Suppose some distance I'm going to take. Will I take that? Wait, let me take it directly in the code. Let's say I'm having some distance and the distances are 0, 10, 15, 20. Then other distance is a set of 10, 0, some value 35, 25, anything. Then we can take some 15, 35, 0, 30. And then here 20, 25, 30, 0. All right. So first of all, I'll generate some cities, a list of cities for, let's say, integer I'm taking. List of cities where I'll take arrays as list for 0, 1, 2, 3. Okay. Let me import Control Shift O. Wait. List, I guess, not imported yet. Import java.util.list. All right. Now I need to get the permutations, sir. So I will check each permutation for shortest distance. Okay. How do we do that? So you need to you need to travel through the path. So you need to get the permutations. So for that, what I will do, before that, I'll just generate some permutation. For that, let's say, I need to design one method, generate permutations for some cities. So I'll design one method named as generate permutations. So I'll design one method, public static, and the method will return a list of integer. All right. For which there is a method. We'll say generate permutation. Okay. For whom? For a list of cities. All right. Now in this, I'll get the list of permutations. Okay. Then what I will do, I'll check if cities dot size, the size of the city is equals to 1. Then in the permutations, the permutation will be added to the list. New array list of cities. Okay. Then in the ending, you can return the permutation. I know it is going to be little bit tough for you. All right. Here only I need to iterate to the city size by I is equals to 0. Yeah, it's allowed. I is equals to 0. I less than cities dot add, or not add, cities dot size. Cities dot size. Then I plus plus. So all the cities will just iterate through. Will just pass through. Okay. So what are the remaining cities I want? List of integer for a remaining city. Okay. For which there is an array list, because duplicates will also be there. Array list of cities. Okay. Now the remaining cities, array wait remaining cities will be removed based on the value of I. Next, the list of integer for the remaining permutation. Remaining permutation will be nothing but return from the generate permutations of remaining cities. Okay. Once you get it, just take support of the for each loop or whichever is easier for you. For list of from remaining permutations. Take it as remaining permutations. I'll add the cities by the help of index. And to the permutations, I will add the perm that I got. Okay. Later in the end, we can return the permutation. All right. It's a little bit tough thing for you to understand at once. I can understand that. People who are done with collection, for them it is easy. Who are not done with collection or not practiced collection, it looks a little bit tough. We discussed about the collection those days, and I asked you to have a little bit like study on it. All right. So do we require more on it? Yes, more will be there. More is there, sir. It's not enough. More is there. Not here. In the main. Okay. What we need then, sir? We need the permutations in the main. List of integer for permutations in which we generate permutation list of cities. Then what's the minimum distance? Minimum distance is equals to, let's say for example, the maximum value of integer range. Okay. Later, what is the base path through which you'll go? Let's say the base path will take as null. Initially, I'm keeping it as null because I don't know what it will be. Default I'm taking null. Later I have to check each permutation for the shortest distance. We have to check each permutation for shortest distance. Checking each permutation for shortest distance. So for that, I'm taking support of for each. Well, I'll fetch each path from permutations, in which the distance is going to be calculated. How will I calculate the distance? How will I calculate the distance, sir? Now, to calculate the distance, it is an operation, no? Correct, na? So we need to have that calculate distance operation again. You need to design that again, sir. Again, tension, sir. Do we have that calculate distance, sir? Do we have calculate distance? No. So you need to design the calculate distance. Design it. Public static. Will I return? Yes, I'll return. Calculate distance. Calculate distance on the array that you got. You've got a lot of distances here for list of path. Now, suppose initially the total distance is 0. Lateral update. Initially total distance is 0. So I'll take support of loop where I'll go up to the size of the path. Whatever path I have got, I'll keep on executing up to there. -1, I++. Now here what I will do, I will update the total distance. I'll update the total distance as addition of distance for the path by getting element available at I along with the next path. Oh, let's do that. Square bracket path dot get of next one is I+1 next path. Once it is done, outside the loop, you can upgrade the path, the total distance as distance of path dot get the path size -1 formula -1 correct formula path of get dot 0 with the first one. Just go to the starting point, get of 0, and then in the ending you can return. You can return the total distance. Now I will invoke that calculate path method for my distance here in the main method. So let's say distance is equals to, I'm invoking the method calculate distance by giving the distance and the path that I get from here from permutation. Okay. Now, if the distance is less than the minimum distance that I have got, then minimum distance is equals to distance. The minimum distance is the distance, and the best path is, let's say the base path. Let's take this best path, not base path. Let's take best path. Best path is path. All right. Once the work is over, I can display the minimum distance is the min distance, and the best path we are going to get is plus best path. The best path is 0, 1, 3, 2. The minimum distance is 80. This is a brute force technique, sir. Brute force approach. We have to find the shortest possible route that visits each city exactly once and return to the starting point. So we just try to get all the possible permutation of the cities, and we calculated the total distance for each permutation. Then with the permutation with the smallest distance is our optimal solution. Okay. Okay. What is this generate permutation is doing here, sir? What is actually happening here? In the generate permutation method, what we did is we tried to generate all the permutation of the cities. Okay, we try to generate all the permutations of the cities that we are taking as input. And from this, one of the cities going to be fixed first. Okay, so that there will be no redundant cycles. Now the salesman may come to the cities in any order. Okay. So if any order the salesman is covering the cities, then it will affect the total distance. So if there is only one city left in the list, then return it as possible permutation. Otherwise, for each city, you have to keep on recursively generating the permutation of remaining city, placing the current city as the front of each permutation. Okay. Okay. What we did here is we just tried to remove the city from the remaining cities. For each city in the list, we remove that city from the remaining city by using remaining cities dot remove. From the remaining cities, we got a list of cities. From the remaining cities, we started removing each city from the remaining cities. And we generated the permutation of the remaining cities recursively. Okay. After that, we are adding the current city to the front at index 0 to the front. Add of index 0 with what you want to add that element. Add the city to the front of each permutation. Each permutation we are adding to preserve the order. Okay. Now you guys are saying what are the permutations we are not understanding at all. Possibilities. For example, let us say, suppose we are having cities 0, 1, 2. Then what are the possible permutations we can get? We can get 0, 1, 2. We can get 0, 2, 1. We can get 1, 0, 2. Possible permutations. 1, 2, 0. What else we can get? We can get 2, 0, 1. Or let's say 2, 1, 0. These values are nothing but different cities. City 1, city 2, city 3, like that. So salesman can go through any of the city. Salesman go to city number 1 first, then city number 2, then city number 3. 0, 1, 2 is nothing but cities. This is just like city A, city B, city C. So first going for A, B, C. First goes to A, then goes to B, then goes to C. Then going for A, going for C, and then visiting B. Then first visiting the first B, then A, then C. Getting it? Then B, then C, then A. Any of the sequence you can visit now. Salesman will visit from one place to another place. So which one is the shortest route they are going to follow? That is the question here. So suppose the cities A, B, C, Aurangabad, Bombay, and Chhattisgarh. So the person may go to Aurangabad, then Bombay, then Chhattisgarh, or may go to Aurangabad first, then Chhattisgarh, then Bombay, or may go to Bombay first, then Aurangabad, then Chhattisgarh, or first Bombay, then Chhattisgarh, then returns to Aurangabad. Any sequence you may go now. You to check it. The possible path the salesman can take throughout the cities. Okay. Then what was that array, sir, we took here, sir? Array we took. What is this, sir? This is nothing but the distance between the cities. Okay. We are having those methods now. We found the minimum distance. We found the we just calculated the distance for each permutations by using calculate distance with distance and path. The total distance for the specified path we took here. So why I took minimum distance as integer dot max values? Initially, I'm saying that this is the max. This is the shortest one. Let's consider the highest. The longest path is the shortest one initially. Think like that. Then slowly, when you compare it, when you're comparing the minimum distance, when you're comparing the minimum distance with the new distance that you got, comparing minimum distance with the new distance that you got. See, calculate distance is invoked again and again inside the loop now. So it will return a new distance all the time. So when you're comparing it, the minimum distance with the distance that you have found. So whenever a shorter path is found, the minimum distance is updated and the best path is set as the path. That's it. Simple. But if this problem is not good for huge number of cities. Okay. There you have to use the, what do we say that, dynamic programming. Okay. So that you will avoid recalculating the same sub problems multiple times. Okay. For that, there will be, for the dynamic programming, there will be better solution for this algorithm will be, more optimal solution will be, you have to check what is that called as H-carp algorithm. Let me just recall H-carp. H-carp algorithm was there very long ago. I studied H-carp. Rabin carp nahi. Rabin carp, not Rabin carp. H-carp. What was that? H-carp, hold carp or held carp, something like that. Held carp, I guess. Held carp, held carp. Bellman held carp, yeah. This algorithm will be used. Bellman held carp algorithm. This is going to be the best one for you. Okay. We are not here for mathematics. Otherwise, I would have told like what will be the recursion relation. Little bit of tricky things are there from the mathematics also. You need to have little bit idea. All right. I know today's this algorithm that you got today is a little bit tricky for you, but I'll suggest you to go for collection chapter first to understand the methods. Because if I keep on discussing all the methods, then we can't complete the problems, the most important problems here. I've already told you guys to go through the collection before continuing with this. So please go through it once. Now we took the city. The cities are here, sir. 0, 1, 2, 3. These are the cities I'm considering. That's a city 0, city 1, city 2, city 3. This is one city. This is another city. This is another city. So what is the shortest distance will be, what is the shortest route I can choose? That's what we did. The best path to reach the all the cities. Okay. And the minimum distance that we are going to get, that also we found. All right. I'm going to upload this complete discussions, whatever we did today in your notes. Please go through it once. And I will try to convert the same program with one line explanation at a time. Okay, I'll share notes for that. Please take out some free time and go through it once. Okay. All right. Linear time meeting. From here we did today. All right then. This was it today, guys. See you tomorrow. We got some sessions. I have to cover it. Yeah, tomorrow also class is there, sir. Tomorrow also same 2 o'clock. Okay. All right then, guys. This was for today. Bye bye, everyone. See you tomorrow. Yeah. Bye bye bye.